Hello everyone, today we are going to study alkalinity of the glass. So the question arises, what is the alkalinity of the glass? So in general we say that alkalinity is just the acid neutralizing capacity of the water. That how the acid present in the water can be neutralized with the glass because the glass have the leaching process of bases from its surfaces, and how it happens and why the base get leaches from the uh, glass surface, and what is the alkalinity of the glass and what procedure can be followed to measure the alkalinity nature of the glass, we will going to study in this lecture. So what is alkalinity of the glass? It is actually the total measure of the acid neutralizing substance in the water. Like how many acid neutralizing substances are present in the water, which get neutralized the glass in which the water is filled. So alkalinity is mainly due to the carbonates which are present in the atmosphere. What happens that they react with the glass and form salts, carbonates, bicarbonates, and hydroxides. So basically, the alkalinity is the determination of the concentration of the bases like bicarbonates, carbonates, and hydroxide, which are formed due to the reactions of uh, potassium and sodium in the glass with the oxides and carbon dioxide in the air. So these are the bicarbonate and carbonates and the bicarbonates and hydroxide, etc., etc., etc. The unit we use for this purpose is MEQ per liter, milli equivalent per liter, or ppm part per million. Okay, so how alkalinity of the glass occurs? Actually, what happens? Why the glass get alkaline, and what is the alkalinity of the glass? So all glass container contains sodium and potassium oxides. It is their composition that they have sodium and potassium oxide in their composition, in their formation. So these sodium and potassium oxides are basically hygroscopic in nature. They absorb moisture from the air, but their size get intact. Okay, so when they absorb moisture from the air, and the air also have carbon dioxide, so when the sodium oxides or the potassium oxide and the atmospheric moisture and the carbon dioxide do react, it forms converted into sodium and potassium carbonates. What it forms? Sodium and potassium carbonates, and these are actually more hygroscopic in nature, and that forms the alkalinity property of the glass. So in water, especially like seawater, sodium and potassium carbonates is present. So, okay, so what happens that these unstable carbonates do react with the glass, and what happens that they start leaching from the glass, and this leaching process of the sodium and potassium bicarbonate from the glass makes the glass fragile, or either it get cracked, or either it becomes a flake glass, or either the glass gets a frosty appearance due to this alkalinity or this leaching process of bases. So why it is important to study about the alkalinity nature of the glass, and how can we protect a glass from leaching or its alkalinity property, what procedure and types of the glass which shows different alkalinity property, we will going to study about this. So why it is important? So quality control test, QC test for glass packaging material. So what are the QC tests to get the alkalinity nature of the glass? So glass is a common packaging material. It is used for either sterile or non-sterile liquids in the pharmaceutical preparation. So leaching is a big dilemma which can happen in the glass because of its types. When it get leach sodium bicarbonate and sodium, or either potassium bicarbonate, when it leaches from the glass, it can react with the pharmaceutical preparations. So it might get any, it might decrease the efficacy of the drug product, pharmaceutical product, or it might make the pharmaceutical preparation poisonous. So it is very important to decrease the alkalinity nature of the glass. So what are the types which decreases the alkalinity and leaching process of the glass? We will study about it. So it leaches alkali from its surface. Leaching of alkali can be reduced but cannot be zero. So basic of the, we can treat our glass with different type of the materials to decrease the leaching reduce the leaching of alkali, but we cannot make a glass which is zero leaching, which is like zero alkali containing glass. It is a totally impossible thing, but we can reduce it, and we can reduce it till a very safe level. Hence, a limit test of alkalinity test is performed before using a particle product. If we are going to use any particular glass for the packaging material, we have to perform a particular alkalinity product test to clear that this glass is suitable for the packaging of the parenteral or IV admixtures, or other for the powders or tablets, etc., etc., etc. So, treatment of the unstable glass, how we can treat the glass to make it more stable, to decrease this leaching process. So, these are the basic some steps, 6 steps, which decreases the alkalinity of the glass or the leaching property of the glass. First of all, what we have to do, we have to wash the glass with running tap water. Secondly, we have to soak the glass in our distilled water. Then what we will do, we will dry in 2 bars of alcohol. Like we will dip the our glass in the alcohol. What this process do when we bath and dry the glass in the alcohol, this process prevents the glass from disintegration or breaking, or it improves its appearance. Its total appearance get improved. So what happened next, that when we add lacquer, organic lacquer in the glass, it delay or impedes the disintegration property of the glass. So lacquer is very important step rather than soaking it in water or alcohol to improve its disintegration, to delay its disintegration. Storing the so after all this process of the treatment of the glass to make it more stable, or improve its acidity, hydrolytic reactions, from saving it from hydrolytic reaction, is we have to store it in our environment such that uh, so that the moisture content is very controlled, so and the carbon dioxide gas do not react with the glass, sodium and potassium oxide, so it's safe from the leaching process, and its alkalinity natures get decreased. So we have to store in which the humidity is not more than 40% to decrease or control the process of the leaching. So our lacquer, as we have mentioned, that um, we will like glaze our glass with the help of organic lacquer or any lacquer material which protect the glass from disintegration. So basically an organic material which is shellac, which is used as a confectioner glaze. It is used for the we can say like to protect glass from the disintegration. It is used. So shellac is basically a confectioner glaze. Like it's like a shining material which protect the glass, and it's a resin that is secreted from a black, female lac beetle. These are the female beetles which secrete the shellac from its shell on trees or in forest in India and Thailand. It is process when the females insects get processed. So we extract the shellac from it and sold as a dry flax. It forms a dry flax. So these are basically dry flax which is extracted from, which is excreted from or extracted from the female lac bug or beetle. So then we dissolve these flakes in the alcohol and it forms a solution and a liquid lac shellac, which we can use as a food glaze or wood finish, organic lacquer, or as a brush on colorant, which gives a protective property to the any material from which we do its lacquer. We spray, rather we varnish it with it. So shellac functions as a tough natural primer, protect it from the disintegration, sheath and odor blocker, and like it's also act as a like taste masking odor blocker. Yeah, either the smell of the glass or any material is it's not good. It also acts as an odor blocker and high gloss varnish. It also gives the glass a varnishing finish, a glossy finish. So it makes it more beautiful and protected glass. So basically there are the 4 types of the glass on the basis of their nature. and of the leaching and hydrolytic stability and the nature of the basic reactions or alkalinity. So first one is type 1, which is the most stable and with the least leaching property, is type 1 glass, which is also known as neutral glass because of its least leaching nature, or highly resistant borosilicate glass. It is also known as a neutral glass because it has like equal amounts of the silica oxide base and boric acid, and it's a very neutral and inert type of the glass. And the type of the reaction, type of the test we perform on this type of glass is the powder glass, which means we powder the glass and perform titration to test the basic bases which are present in the glass with the help of any acid 0.2% normal H2SO4 solution, and that determines how many what is the concentration or what is the EQ per liter of the base which is present in the glass. Second test, which is treated soda lime glass. Treated soda lime glass, as known for the name, we treat this soda lime glass with silicon dioxide to make it more protected, to decrease its leaching property, or increases stability or increase its hydrolytic reactivity, decrease to decrease that. So what the type of test we perform is a water attack test. Water attack test is basically we give temperature with the help of autoclave to and we actually apply temperature so that the process of leaching get increase. And when the process of leaching get increase, the reaction of the alkalinity get increase, and all the basic bases get leached into the glass water, pure water, which is present in the glass. And then we perform titration same as the water attack test. But in the powder glass test, we crush the glass, but in the water attack test, we do not have to crush the glass. Just we simply apply pressure with the help of autoclave, and all the basics get leached uh, into the water, pure water, and then we perform that test on that pure water. Then third one is soda lime glass. It is not treated with the silicon dioxide, so it is the glass that shows somehow the process of leaching. So the type 1 and type 2, because they are stable and hydrolytic stably, and they are less reactive, and they are inner type of the glass with least leaching property. So the parenteral injections and impures are made up of the type 1 and type 2 glass. And the type 3 glass, because they are not treated and their leaching property is far more greater than the type 1 and type 2. So the type 3 glass is mostly used for the IV powders, which are not do not have water in it, or any solvent in which the leaching process may happen, or this reaction may happen. So these are mostly used to store any tablets or any laminates or ointments or any powders for reconstitutions. And the test here is performed is a powder glass test. I have already mentioned about what is the procedure of the powder glass test, and in further slides we will also study in details about the powder glass test. Then the third type is the type 4 or O type or type NP glass. So this is general purpose of the soda lime. It is a powder, so it's general purpose for the soda lime. It is a glass with maximum leaching property, and mostly we do not store parenteral dosage forms or powder in it. And this is mostly used for the topical products like tablets or any ointments for storage. So this is the glass of the least quality and with the maximum leaching property, type 4 glass, and the test we perform is powder glass test. Then comes the type of the glass on the basis of its property and suitability. What kind of packaging material and the glass is used for the packaging of the parenteral dosage forms, or either tablets, or either uh, IV reconstitution powder. So type 1 glass is known as a highly resistant borosilicate glass, and its alkalinity is removed by using boric oxide. So actually what we do, in the type 1 glass, we treat the glass with the boric oxide to neutralize the oxide of the potassium and sodium, which do react with the moisture in the air and the carbon dioxide to form sodium bicarbonates and the potassium bicarbonates. So we already have treated the sodium oxide and potassium oxide, which is present in the glass, with the boric acid to neutralize the uh, leaching alkalinity of this glass. So that's why this is neutral glass. Actually, boric oxide and sodium oxide get involved into a neutralization reaction, which makes this type 1 glass highly resistant to any reactivity or any leaching property. And this glass is also known as neutral glass and borosilicate glass. And this is mostly used for the storage or administration of the parenteral dosage forms. Then comes the type 2 treated soda lime glass, as shown from the name. It is a soda lime glass, but it is a treated soda lime glass. It's not a simple soda lime glass. But type 3 is a simple soda lime glass, but type 2 is a treated soda lime glass. So hot surface type 2 is treated with the sulfur dioxide or either ammonium sulfate or either ammonium chloride. So what we do, we treat the type 3 glass with sulfur dioxide, ammonium sulfate, or the ammonium chloride. Third comes the suitability. It is also used for parenteral administration. It is safe, it's least leaching property. And then comes the type 3 soda lime glass. It is untreated soda lime glass, and it is an alkaline glass having high percentage of lime. So it do leach. The reaction of alkalinity do happens here. So once it gets contact with the moisture and the carbon dioxide, it do forms sodium bicarbonate and potassium bicarbonate. So it's in the type 3 glass, leaching reaction do occurs, but it is um, so as compared to the type 1 glass, just in which the leaching reaction do not occur, but here do occurs. So not generally used for the parenteral dosage form because it can react with the water and the moisture present in the parenteral dosage form. So it is mostly used for the powders for the ideal mixtures with no water in it. So it is safer for that storage material. It is used for the packaging material of the powders. IV powders are or either oral tablets or topical preparations, any ointments like that. Then comes the type 4 glass or the type NP glass or type O glass. It is general purpose soda lime glass. It is the glass with the maximum leaching property. So it has similar composition as type 3 glass, but there is guaranteed similar property. They both have the relative similar leaching property, hydrolytic and stability, and the reactivity is either same. It is not very safe for the parenteral dosage form. So it is used for the tablets. Seldom we have seen the tablets which are stored in the glass containers, which is mostly amber in color, and that is type 4 glass. And storage of the tablets or any oral solution or external liquids or the ointment which are not stored for a long period of time. So then we move toward the tests which are performed on the glass test. So first test which we'll use to study about the alkalinity of the glass is powder glass test, and the second one is powder glass test, and the second one is, the name it, I have mentioned about its water attack test and powder glass test. So what is powder glass test? This test is official in USP and IP, International Pharmacopoeia, and United States Pharmacopoeia. In this test, alkalinity as well as the glass constituents are measured. So all the constituent of the glass and the alkalinity nature of the glass is measured. So this is 2-in-1 procedure. Simple preparation, it has a very simple process. What we have to crush the glass, then we will make sure that the size of the powder glass is uniform, and then we will perform a titration procedure in it and autoclave it. This is just a procedure step by step. I will tell you about this. So sample preparation, how we will prepare the sample. First of all, we have to rinse the water. Means we have to use water to rinse at least 6 or more containers. Then we will dry the container in the air. Then we will crush the containers or the glass, or about like, first we will crush it to the size of the minimum 22 millimeters. Then we will divide this glass into three portions, and the first portion will be uh, further deteriorate, and we will decrease the size to about so like it can pass through the sieve 20, and remaining two portions, then we will again triturate it in the pestle and mortar, and to the sieve number 20, and this empty in the mechanical shaker for about 5 minutes, because the sieve 40 is of small size, so we can use mechanical shaker for 5 minutes so that the powder get uh, filter or get passed through the sieves. Separate samples on the glaze paper and pass over the magnet. So if any metal is present in the glass, or any metal get in in the glass powder during the process of trituration or size decreasing, so uh, it get detached from here, and then it get excreted, or it get out from the glass powder. So then what we will do, we will transfer that glass in the glass powder into a conical flask, and we will wash it, and then we will dry the glass for powder for about 20 minutes at 140 degrees, and we use test sample for within 48 minutes. So basically autoclaves are used here. So I will tell you a brief about the autoclave. So autoclave is basically like a pressure cooker in which you increase the pressure so that the temperature and the boiling point of the water get decreased, and temperature get higher, and the same procedure get in a small period of the time. So so we will decrease the pressure to a limit that the temperature get so high that the process of autoclave and the sterilization get faster. So basically types of the autoclave which we use is type pressure cooker type, common lap autoclave, vertical autoclave, and horizontal autoclave, and the large automated hospital autoclave. So the powder test, as per the USP, the process is the following. We have to take 10 gram of the powder of the glass that we have uh, already prepared the sample, and then we will transfer it into our 250 ml of the conical flask, and then we will digest it with high purity water in bath at 90 degrees. We will give the pressure at 90 bars so the process of alkalinity get faster. So then we will add the conical flask containing 50 ml of the high purity water. Then we will add 50 ml of the high purity water. Then we will cap the flask, and we will autoclave for 10 minutes so that the process of alkalinity get faster. Then we will close and cook, and we will adjust the temperature for like about 121, say 121 to plus minus 221 degrees. Then temperature can vary from 121 degrees to 221 degrees in between, or either the minimum or maximum for about 30 minutes. It depends on how faster we want the process to happen. So then powder test continue. Then we will reduce the heat with the time, and we will let the autoclave to cool, and then we will let the glass to cool, and cool the flask in running water. So increase to fasten the cooling process. We can even run cool water over the flask, and then we can decant the water and wash the residual glass for about 15 ml of the pure water for about 4 times, and then we will also use that residual glass and decant portion, and we'll mix the residual and decant water, and then we will add about 5 drops of the methyl residual solution in the decant and residual glass pure water, and we will perform the process of titration with the 0.02 normal sulfuric acid, and we will record the volume of the sulfuric acid which is used to neutralize the color of the uh, methyl red solutions to colorless. That will determine the amount of the base present in the glass. Second test which is performed to test the alkalinity of the glass is water attack test. It is a very simple test We don't have to crush the glass. We don't have to prepare for the sample solution. What we do, simply autoclave the glass at high temperature in a stress condition so that the process of alkalinity gets faster, and all the alkali, sodium bicarbonate, and the potassium bicarbonate get leached into the glass at high temperature and process under lot of pressure, and the process of alkalinity gets faster, and then we will perform that titration process on that water which is present in the glass. So this test is used only for containers that have been exposed to sulfur dioxide fumes under controlled humidity conditions. Such treatment neutralizes the surface of the alkali. So basically, when we have, as we have studied in the type 2 glass, when we treat the type 2 glass with the sulfur dioxide, it neutralizes the surface of the alkali. Now, this type of glass become chemically more resistant. The principle involved in this water attack test is to determine whether the alkali leach from the surface of container within the specified limit or not. Like we have treated the soda lime glass with the sulfur dioxide, and we have mentioned now this is a resistant glass now, but we have to test either this glass is now resistant or not. So what we will do to check the nature and the chemical inertness of the type 2 glass, we will perform water attack test on the type 2 glass test. Okay, so this is the test for the water attack for the type 2 glass. So to test either the process of neutralization of the type 3 glass with the sulfur dioxide to type 2 is done or not, we perform water attack test on the type 2 glass. So what we do, the principle involved in the water attack test is to determine whether the alkali leached from the surface of the container within the specific limit or not, or either it is unleachable glass or leaching glass. Since the inner surfactant is under test, entire container ampule is to be used. We use entire container or ampule which we have to test. The ampule, the amount of acid that is necessary to neutralize the released alkali from the surface is estimated, and the leaching of alkali is accelerated using a limited temperature of specified time. We can't wait for days, for the days and months and weeks to happen the process of leaching. So what we do, we give pressure and we elevate the temperature to accelerate the process of leaching, and we use methyl red indicator to determine the endpoint, and we will determine the amount of the base which is leached out from the glass, type 2 glass, in this acid-base titration process to measure the amount of the base with the help of the standard 0.02% normal base. So this test is used to determine alkali leaching out from the surface of the type 2 glass container, mainly based on the alkali released from the glass and the influence of the media used. The amount of the glass acid is neutralized with alkali from the surface estimated. Like how much amount of the alkali is leached from the glass, we estimate its quantity with the help of standard acid, which is 0.02% normal H2SO4, and the indicator used is methyl red used to determine the endpoint. So this is basically the flow chart for the acid attack test. What we have to do means 3 or more containers with high purity glass. Then we have to fill the container with 90% of the overflow capacity. What we do, cap the flask and autoclave it for 60 minutes. That would give the accelerated leaching process. And then what we'll do, empty the container, cool the container, and we transfer it to 250 ml of the conical flask to our volume of the 100 ml. Add 5 drops of methyl solution in the water, which was in the container when we autoclave it. So then we will titrate it with 0.02% normal sulfuric acid while warm. The condition is we have to perform this reaction in warm water. To record the volume as consumed means we have to record the volume of the acid. 0.2% normalized sulfuric acid is used to neutralize the base present in the water in which we have added methyl red solution as an indicator. The volume should not be exceeded. So what volume should be used as is mentioned in this test. So highly resistant borosilicate glass, we perform powder glass test, and limit of sample size can be any. And the limit of the base, which is is 1%. Mean if the limit exceeded in from 1, then we can say that this is not type 1 glass. This is something not stable. This is something non-inert, and the process of leaching do occurs here. So limit ml of 0.2% and normal H2SO4 is only 1. If it exceeds from the 1, we say it is either soda lime or treated soda lime or either general purpose soda lime glass. It is not highly resistant borosilicate neutral glass. So secondly, treated soda lime glass, water attack test we perform, in that we don't perform water powder glass test. So if we use 100 ml of the water, then the limit is 0.7% acidic solution. Like means 0.7% ml of the 0.2% normal ml neutralizes the indicator colors. And if we have over 100 ml of the sample, then only 0.2%, 0.2 ml of the 0.2 normal H2SO4 neutralizes the indicator to a colorless. And in the type 2 glass, as we have indicated, that this would have a high leaching property. So the amount of the base would be high. So the amount of the H2SO4 solution would be also high. It would be 8.5 ml of the 0.2% normal and H2SO4, which will be used to neutralize the amount of the base which is present in the water. So it shows that here the process of leaching is more. So it is a class of high hydrolytic instability and more leaching and alkaline in nature. And the type 4 glass, which is general purpose soda lime glass, we perform powder glass test, and we can use any concentration of the ml of the size of the limits. But the limits for the acid is 15, mean maximum 15 ml of the 0.2% normal H2SO4 neutralizes the glass when we perform the process on it. So this was about the alkalinity of the glass test. For the quality control test of the glass to determine the nature and type of the glass, this was all from the alkalinity of the glass test. Thank you so much.